All right, so we've got 7G.2 we'll begin with, and this is lots of fun. I think it's easily the funnest part of this unit. And we'll just get straight into it, and I think I'll show you the calculator skills as they pop up. And it's a real continuation on from what we were doing yesterday. So we'll start with a recap of what we did yesterday in A, and then move on to the rest. So we've got the probability that a seed will germinate. So that means it's a seed at the moment, and it's going to grow into a plant. So is 0.85. Now we have 6 seeds in a pot. All right, so we're putting 6 seeds in a pot. Find the probability that exactly 5 seeds will germinate. Given 6 seeds in a pot, find the probability of germination of exactly 5 seeds. So this means, what's the probability that our variable, is the number of seeds that germinate, is equal to 5? And so following from the binomial distribution formula yesterday, this would be 6 trials, 5 successes, multiplied by the probability of a success to the power of the number of successes, multiplied by the probability of a failure to the number of failures. So if we were to continue this exercise based on what we know, that's how we would answer it so far. I'm going to show you a way to answer that exact same thing, but a little bit faster. Alright? Because this kind of question, we're not really looking for the syntax or the input, we're just looking for the answer. What's the answer to A, the probability that we have 5 germinate? So there's 2 strategies we can use, and on our calculator, I'll show you both, and you'll probably become more familiar with the second one, I think. So first let's go to Menu, Statistics, Distribution, Binomial, and then we've got 2 options. We've got BPD and BCD, and we'll use both. Now, all we're going to start with is we look at this, it says x equals 5. So that means BPD, okay, because it's an exact event. BPD is exact event, one exact event is BPD. So if we press that, all right, and it will bring up a number of options for you. So distribution, binomial, BPD. And so we've got X, num trial, and P. They're the things we need to fill in. X, N, and P. Now, what X is the number of successes. So we're going to put 5 there. What N is the number of trials. We're going to put 6 there. And what P is the probability of germination, which is 0.85. So we'll put that there. So if we type those in and evaluate it, we'll get our probability, and I'll come to see if people are a bit stuck at the moment. 0.85, and we've got 0.3993, and then to 3 significant figures, 0.391. Okay, everyone got find the BPD menu?
Is that it?
Yes, that's it. Yep. Now you. Yeah. Oh, now let's change it to say statistics. Yes, that would be good. Yeah, it might be.
And then you go to distribution.
But if I do, no. You can do it in run that. Yeah, that was right. And set it to variable, and now we go. How about you, fellas? Yeah, no worries. Excellent. Okay.
Yeah, but this one. Yeah, you can go both ways.
Alicia?
Yeah, but he probably just read ahead.
Yeah, I was reading ahead.
He's getting. All right. So if you type in this, it will dish out the same answer as this. So really, it doesn't matter which one you do, unless you're asked specifically to use binomial formula, which is this one. Okay. So it doesn't matter which one you do. This is obviously a fair bit faster. There is another way we can type it in as well, and I'm just going to show you that right now while we've got this same problem. So let's go to run that. Okay, so Tyler, do you want to tell us how to do this?
I think go to start.
So you go to run that. And how do you bring up stat? Option.
Option.
You press option. And
Didn't
then
mean to say that loud.
follow the same steps.
Where is option? I'm beating you. Where's option?
The option button is next to the shift button.
Oh, okay. Then start.
And then just follow the same thing.
Okay.
And then what you type in your calculator,
Oh, have you got it twice?
alright,
Go delete.
in your calculator it's just going to pop up with this. So stat, distribution, binomial, BPD. Pops up with binomial PD bracket. Okay, and so what you need to do is type in x, comma, n, comma, p.
Oh, okay.
Alright,
How do I run an X?
so the comma, guys, is under the cos button. Why? Because that's where it belongs. Okay, so what you'll type in is 56.85 equals. Alright, so it's an even faster way of generating the same solution. So my recommendation is to become familiar with the run map, then you don't need to hop in and out of stats. So, alright, let's move on to B. Alright, so that's the probability of exactly 5 seeds germinating. Part B says, how about the probability of between 2 and 4 seeds germinating exactly? So if you consider a pot of seeds, right, and we've got 6 of them in there, you could be really unlucky and have 0 germinate, or you could be really lucky, 3, 4, 5, 6, and have 6 germinate. There's all of these possible outcomes, right? And we're asked specifically about 2, 3, or 4 germinating. We're asked about this event. Now, based on what we already know about binomial distributions, what we would do is calculate the probability of event 2 plus the probability of event 3 plus the probability of event 4. So you could do that, all right, but it's 3 calculations. Instead, we have the binomial cumulative distribution, which adds together discrete probabilities for us. And so what we're going to do, let's do it in run map. We go option, stat, distribution, binomial BCD. And so it'll bring up something pretty similar to what we had before. And we input the lower boundary. The lowest boundary that we're including is 2, comma. The upper boundary, the highest boundary that we're including is 4. The number of trials, how many seeds are there in the pot? 6. And the probability of success, 0.85. Okay. 2, 4, 2, 4, 6, 0.85. 0.223. 1, 0.223. Okay, everyone okay with B? Alright, let's move on to C. Find the probability that less than 3 seeds. Okay, so less than 3 seeds is this. So if it's less than 3, alright, think of, or if you need to, if it helps me, is list the outcomes, and they're saying less than 3, okay? So that means values 0, 1, or 2. So that means our BCD calculation now is from 0 to 2 out of 6 trials, and the probability of a seed germinating 0.85. So we'll crunch that one. Between 0 and 2 out of 6.85. Much smaller, 0.00. 5885. 4 figures, round the 4th. Okay, that's C. How about more than 3 seeds? Okay, so for D, we're asked, what about X being larger than 3? So that's describing 4, 5, or 6. So our calculation then, between 4 and 6 out of 6.85. So that's quite more likely, 0.953. And then the last one, how about exactly 3? Okay, when it asks for one exact outcome, that's BPD. So we're going BPD. We have 3 successes, 6 trials, and the probability of success is 0.85. Three, 6.85, and I've got 0.0414. I'm going to round it straight away here just because I've got limited space. All right, what is the significance of the sum of your answers to part C, D, and E? Who wants to guess? Equals 1. Excellent, okay? Let's explain why. In the first part, C, we said the probability of being less than 3, that's these events. In part D, we said more than 3, that's these events. And in part E, we said this event. And when we add the probability of all possible events together, the probability of all possible events will always be 1. Okay, so the significance of it is all probable events sum to 1. Now, I just want to point out one more thing that's not listed here. Maybe we can add on a part G, which is how would you calculate 6 seeds germinate? 6 out of 6. So, based on what we know, okay, it could be like this, 6 successes. So we change that to a 6, and that would be a 0. In here, we could write it like that. Okay, I'll write it as probability. Now, both of those would be correct. Even then, based on probability, what it requires is that the first seed to germinate, the probability of that happening is 0.85. And then we have to have the second seed germinate, which is 0.85. And then the third seed germinate. Okay, all the way up to the 6th seed. Times 0.85, okay, which is going to equal what? 0.85 to the power of 6.
0.377.
Yep. So the point of this though is to say that's the fastest way to calculate that. We're talking about all seeds germinating, okay, well the probability of a seed germinating to the power of the number of trials we've got. That's going to be the fastest way to do it. And this calculation actually means the same as this one. I mean, mathematically it's true, but I think it's more obvious than it just being true because when we evaluate them they're the same. What can we see the link between these two? The 0.85 and the 6 are the same. Anything to the power of 0 is 1. 1. Yep, so that's a 1. And this is going to be a 1 as well because this is the extremities of Pascal's triangle and all of the diagonals on Pascal's triangle. So we've got 1 times 0.85 to the 6 times 1. It's the same as that. Okay, so let's leap into this exercise. That's where we'll dedicate most of our efforts today. And we will finish with G3 a bit later on in the lesson. It's a fair bit shorter G3. So yeah, let's get into G2.